In this video, we're going to graph a cosecant function. So we are going to use some graph paper near the end, and we're also going to use these same set of steps that we've been using. So if you want a copy of either of these, check the video description. There's a couple links in there. You can click. One will open up this, one will open up this, and you can print them out and follow along if you'd like. Okay, so we talked a little more about these steps when we did the secant video, so we're just going to use the exact same steps. Okay, so for secant to cosecant, it's really exactly the same. The only difference is the equation that we use in step 2 here, in step 1, when we find the general equation of the vertical asymptotes. Okay, the equation is a little bit different that we use, but otherwise it's exactly the same. The steps are the same. Okay, so let's go ahead and jump right into this. Okay, so first what we want to do is find the period t equals 2 pi divided by the absolute value of omega, and find the general equation of the vertical asymptotes. Okay, so we talked about why the period is what it is in an earlier video, and we talked about how to find the asymptotes, so we're going to do that exact same process without explaining why it is the way it is, because we covered that in a separate video, and we don't want to spend too much time here going over that. So 2 pi divided by the absolute value of omega for the period, denoted capital T. So what is omega? It's the thing being multiplied by the x. Remember, the general form is this right here, a times the cosecant of omega x minus 5 plus b. So omega is the thing being multiplied by the x, which in this specific case is just 3. Okay, so that's good. So for our specific problem here, omega, not omega x, just omega is 3. Okay, so if omega is 3, then the period t equals 2 pi divided by the absolute value of omega. Okay, well omega is already a positive number, it's 3, so the period is just 2 pi divided by 3. Okay. So that's, it's not really, it's not a terrible number, but we could have a nicer period. But anyway, we'll worry about that later. So now for the rest of step 1, find a general equation of the vertical asymptotes. So let's do it like we've always been doing it. So first what we do is we say original, as in the original general equation of the vertical asymptotes for just plain old y equals cosecant of x. So for plain old y equals cosecant of x, oops, that's not what I want to write. The general equation of the vertical asymptotes is x equals k pi, where k is any integer, and we did explain that in an earlier video on graphing or finding the vertical asymptotes for functions like this. So this is what we use. Now, we don't have y equals cosecant of x, we have y equals this big mess here. So now what we say is new, as in the new general equation for the new cosecant function we're given here. So what we do, just like we always do, we take everything inside of the cosecant, which is 3x plus 2 pi. You take everything inside of the cosecant, so take 3x plus 2 pi, and set it equal to k pi. Okay, and then what we do is we just solve for x. Okay? So we use k pi because it's cosecant, and then just like we always do, we take everything inside of the cosecant, 3x plus 2 pi, and set it equal to k pi, and then we solve for x. Okay, so we solve for x because we're looking for the general equation of the vertical asymptotes, so it has to be x equals something, and it's going to involve k because it's a general equation, not for just one specific asymptote, it's a general one covering all of them. So subtract 2 pi from both sides. If we want to solve for x, so we subtract 2 pi, and we get 3x equals k pi minus 2 pi. Okay, and then divide everything by 3, so x equals k pi minus 2 pi, all divided by 3. Okay, so we could split it up into 2 fractions if we want, but let's leave it as 1 fraction because it'll make it a little bit simpler when we have to evaluate and find specific asymptotes coming up soon. Okay, so and also let's say comma, k is any integer, just to be thorough here. Okay, so we have that going on. So let's go back to our steps. Okay, so that's it for step 1. Find the period and find the general equation of the vertical asymptotes. Okay, the period is 2 pi over 3 we just found. And the general equation of the vertical asymptotes is this guy right here. X equals k pi minus 2 pi all over 3. And yeah, there are a few different ways to write that, but let's maybe just leave it like that just to keep things simple. So next, find 3 consecutive asymptotes by plugging k equals -1, k equals 0, k equals 1 into the general equation. Okay? So again, we don't have to use those specific values of k, but we want to keep it as simple as we can, and we want to use values of k that are right next to each other. They definitely have to be consecutive no matter what you do. They have to be 3 consecutive values of k, and they have to be integers, right? K represents any integer. So just to keep it relatively simple, there actually are better values we could use, technically speaking, but just to keep it standard and simple, let's just use -1, 0, and 1. Okay, they aren't bad values, but They aren't really the best, but they're second best, so to speak, by a very close margin. Anyway, it doesn't really matter. So we'll set up our chart like we always do. And so we're going to do k and then VA for vertical asymptote. So k is -1, 0, and 1. Okay, so when k is -1, what do we have here? We have x equals -1 times pi minus 2 pi, all divided by 3. Okay, so negative pi minus 2 pi is -3 pi, all divided by 3. So the 3's cancel, and we're just left with negative pi. Okay, so x equals negative pi is our first vertical asymptote here. Okay, and again, it's the equation of a vertical asymptote, which is a vertical line. So make sure that we actually give this as an equation, x equals negative pi. Okay, it's a vertical line, so it's x equals some number. So we don't want to just say negative pi. Okay, make sure we say x equals negative pi. So we want to be thorough and safe about it and correct about it. Okay, so what about when k is 0? When k is 0, we have x equals 0 pi minus 2 pi all over 3. 0 pi is just 0, so this is -2 pi over 3. Okay, so x equals -2 pi over 3. Okay, now what about when k is 1? When k is 1, what do we have? We have x equals 1 times pi minus 2 pi all over 3. Pi minus 2 pi is negative pi, so this is negative pi over 3, and that's it. So x equals negative pi over 3. Ugh, not liking these numbers really. Okay, so that's it for that step, right? Yeah, step 2. Find 3 consecutive asymptotes by plugging k equals -1, 0, and 1 into the general equation. This is what we just did. And again, we don't have to use these values of k, but just to keep it standard, let's go ahead and just use those values. All right, now what's next? Take the first and second asymptotes and divide the interval between them in half to get an x value, and do the same thing with the second and third asymptotes to get another x value. Okay, so just like with the secant video, you know, it sounds like a mouthful, but it's really not that bad. So what we do is we just set up our little interval here. Okay, so put our first asymptote here at, so that's x equals negative pi. Put our third one over here, negative pi over 3. Okay, and then the second asymptote is directly in between them. Okay, so always like that, always, always, always. For secants and cosecants, always, always, always like that. Okay, that's why it's important to use 3 consecutive integer values of k, because 3 consecutive values of k are going to give us 3 consecutive asymptotes. So since we have 3 consecutive asymptotes, we can set up our chart like this. Okay, that's why that works the way it does. Okay. Now the step said take the first and second asymptotes and divide the interval between them in half. So just take this interval right here and divide it in half. That'll give us an x value here. What is it? Well, to figure out what it is, we add these two guys up and divide by 2. Okay, so it's halfway in between, so it's like an average. So we average these guys. Okay, add them up, divide by 2. So that's going to be, let's come up here. Negative pi plus -2 pi over 3. Okay, dividing by 2, it's the same thing as multiplying by half, so we'll do it like that. Now we want to get a common denominator in here, okay? So negative pi and then -2 pi over 3, so common denominator. Let's move the plus sign over, so this will be multiply this by 3 over 3. Okay, so this is really -3 pi, and then plus -2 pi means -2 pi. So first let's do this, -3 pi over 3, and then -2 pi over 3. Okay, and we still have times 1/2 out here. Oops, okay. So then this is -5 pi over 3 times 1/2. So this whole thing altogether is -5 pi over 6. Ugh. Okay, -5 pi over 6. All right, now remember the step said to do the same thing with the second and third asymptotes to get another x value. Okay, so here's our second asymptote, here's our third asymptote. So we divide that interval between them in half to get another x value. So we add up both these guys and divide by 2. At least we already have a common denominator in that case. So -2 pi over 3 plus -pi over 3. Divide it all by 2, same thing as multiplying by a half, so let's write it like that so we can avoid complex fractions. Okay, so -2 pi over 3. So plus negative pi over 3 means minus pi over 3. So we're still multiplying by a half out here. So then that equals -2 pi over 3 minus pi over 3, so that's -3 pi over 3. and we're still multiplying by the half out here. So the 3's cancel, and we have negative pi times 1/2, which is just negative pi over 2. Okay, that's not terrible. Okay, so negative pi over 3, negative pi over 2, negative 2 pi over 3, negative 5 pi over 6, negative pi. We definitely could have better numbers, but you know, they could also be a lot worse, so I guess we'll just be happy with it. Okay, that's it for that step. So take the first and second asymptotes, divide the interval between them in half to get an x value, and do the same thing with the second and third asymptotes to get another x value. That's it for that step. Now step 4, find the y values at the two x values found in step 3. Okay, so here, when we started step 3, you know, we had asymptote here, asymptote here, asymptote here, and we found these two new x values, okay? So we want to find the y values here, okay, because remember the asymptotes, like we just said, the asymptotes are at the other 3 x values, okay? So we cannot evaluate the function at this point, or this point, because the function is undefined at these points, okay, because it has vertical asymptotes there. Okay, so because it has vertical asymptotes, we cannot evaluate the function there, so we can only evaluate the function at these 2 points, which is exactly what we're going to do. And it's exactly the same thing with secant functions, right? So the same thing happened when we did that secant function earlier in a different video. Okay, so let's evaluate this function at negative 5 pi over 6, and then again at negative pi over 2. So when x equals negative 5 pi over 6, what's going on? Okay, so again, we're doing step 4 here. Find the y values at the 2x values found in step 3. So again, in step 3, we already had these 3x values from the previous step, okay, because that's where the asymptotes are. And then in step 3, we found both of these x values. Now we're going to evaluate the function at the x values we found in that step, okay? So when x is negative 5 pi over 6, what do we have? We have y equals 4 times cosecant of 3 times negative 5 pi over 6, okay, 3x, and x is negative 5 pi over 6, oops, negative 5 pi over 6, and then plus 2 pi, and then we have a plus 1 out here, okay? Okay, now it's kind of a mess here, let's simplify that separately. So 3 times negative 5 pi over 6 plus 2 pi. So 3 goes into 6 twice, so this is negative 5 pi over 2 plus 2 pi. Let's get a common denominator, so multiply this by 2 over 2. So this is negative 5 pi over 2 plus 4 pi over 2. Okay, so negative 5 pi over 2 plus 4 pi over 2 is negative pi over 2. Okay, so that actually simplified kind of nicely. Okay, so negative pi over 2. So this is equal to 4 times the cosecant of, remember this whole thing, we just simplified this entire expression and it turned out to be negative pi over 2. So negative pi over 2, and then plus 1 here. Okay, so let's get rid of this. Now again, here's where our knowledge of the unit circle comes in handy. So cosecant of negative pi over 2, a few different ways to think about it, but no matter how you think about it, you're going to get cosecant of negative pi over 2 is negative 1. So this is 4 times negative 1 plus 1, which is negative 4 plus 1, which is negative 3. Okay, so let's see, when x is negative 5 pi over 6, we just found out the corresponding y-coordinate is negative 3. So this gives us the point negative 5 pi over 6, comma, negative 3. Okay? Okay, so now we do the same thing at the other x value here. So we just did it with negative 5 pi over 6, now we do it again with negative pi over 2. So when x is negative pi over 2, what's going on? Well, let's figure out what's going on. So when x is negative pi over 2, remember we're using the 2x values that we found in step 4, or rather step 3. Okay? We're doing step 4 right now, and then we're using the 2x values we found in step 3, which is this one and this one, negative 5 pi over 6 and negative pi over 2. Because we have vertical asymptotes at the other 3, so we cannot use those. Okay, the function is undefined at those points, at those values of x. Okay, so anyway, at x equals negative pi over 2, we have y equals 4 times the cosecant of 3 times negative pi over 2 plus 2 pi. 3 times negative pi over 2 plus 2 pi. and then we still have that plus 1 floating around out there. So, so let's simplify this separately again. So 3 times negative pi over 2, that's negative 3 pi over 2. And then plus 2 pi. So common denominator, multiply 2 pi by 2 over 2. So this is negative 3 pi over 2 plus 4 pi over 2. Okay, and then the negative 3 pi over 2 plus 4 pi over 2 simplifies to just plain old pi over 2. That's lovely, that's great. Okay, so what we just found out was this entire expression inside the cosecant exactly equals pi over 2. So this is 4 times the cosecant of pi over 2. And then plus 1. So cosecant of pi over 2, knowledge of the unit circle really comes in handy here. So cosecant of pi over 2 is just 1. So this is 4 times 1 plus 1. 4 times 1 is 4, 4 plus 1 is 5. So when x equals negative pi over 2, we just found out the corresponding y-coordinate is positive 5. So this gives us the point negative pi over 2, comma 5. Okay. Go back to our steps. So that was step 4, find the y values of the 2x values found in step 3, which were negative 5 pi over 6 and negative pi over 2. And remember, the asymptotes are at the other 3x values, so we can't evaluate the function there. Now step 5, if a scale is not set up on the graph, let the x-axis scale be t divided by h. Remember, t is the period. Okay, and we're dividing by 8 so that we have more room to work with, which we'll see when we get to the graph. And let the y-axis scale be something convenient and relatively similar. Graph the asymptotes, plot the 2 points that we just found, and use them as guides to draw the graph. Okay, so a lot of words there, but really what we have to do is not terribly complicated. So actually, before we go to the graph, let's take t and divide it by 8. Ugh, okay. So t divided by 8 is the same thing as t times 1 over 8. So this is 2 pi over 3 times 1 over 8. Okay, so simplify that. 2 goes into 8 4 times, so oops, already have the equal sign. So this is pi over 3 times 1 over 4, which is pi over 12. Oh, terrible. That's awful. Okay, so our x scale is going to be pi over 12. What that means is if we go to the graph, okay, do we have to use that? No, we don't really have to use that. Technically speaking, we can use any scale we want, as as long as it makes the graph easy to see, and as long as it makes sense for us. So let's set up our. So this grid kind of got tilted when we printed it, but so it's going to be y-axis here, and I guess we'll put the x-axis here. Sure, why not? Okay, so here's our x-axis, y-axis. Okay, now again, what's nice is if you're doing this on a quiz or a test, you might already be given a scale just to save time so that you can focus on the more important things for trig. But if you're not given a scale, this is one way to go about doing it. Just take the period. For cosecant and secant, take the period, divide by 8. Why 8? Why not 4 like tangent and cotangent? Well, you could use 4, but it won't give you enough room to work with, I don't think anyway. It's still doable, but everything will look pretty squished in. Okay, so anyway, let's zoom in here and set up our scale. So, pi over 12, okay, this is 2 pi over 12, which is pi over 6. This is 3 pi over 12, which is pi over 4. This is 4 pi over 12, which is pi over 3. Okay, so let's actually, we're going to stop there and then let's go to the left. This is negative pi over 12. This is negative pi over 6. This one is negative pi over 4. This one is negative pi over 3. Okay, so it's the exact same one, it's just in the opposite direction, in the negative direction now. So negative 1 pi over 12, negative 2 pi over 12, negative 3 pi over 12, negative 4 pi over 12, negative 5 pi over 12. Ugh. Negative 6 pi over 12, which is negative pi over 2. Negative 7 pi over 12. Ugh. Negative 8 pi over 12, pull out a common factor of 4, that's going to be negative 2 pi over 3. That's reasonable. And then negative, what was that, negative 8 pi over 12, so this is negative 9 pi over 12. Pull out a common factor of 3, that's negative 3 pi over 4. negative 10 pi over 12, pulled out a common factor of 2, that's negative 5 pi over 6. Negative 11 pi over 12 cannot be simplified. And then negative 12 pi over 12 is negative pi. Okay? All right, so that's enough to label there. And now, so if we go back to our steps here, let the x-axis scale be t divided by 8, so what we just did. Let the y-axis scale be something convenient and relatively similar. Okay, so convenient means make it convenient for our y-coordinates. Our y-coordinates are negative 3 and positive 5. Okay, so basically our y-axis scale shouldn't be pi over 12. We shouldn't have anything with pi, because our y-coordinates are integers. Okay, they're straight up integers, negative 3 and 5. So pi over 12 is, so pi is about 3.14-ish. So 3.14-ish divided by 12 is a little more than 1/4. Okay, so 1/4 might be kind of small to use, so let's use 1/2 as our scale. Okay, so it doesn't have to be as close as possible. The y-axis scale doesn't have to be as close as possible to x, just relatively similar. Okay, so we'll let each grid box in the y direction be 1/2 unit. So that'll be 1, that'll be 2, that'll be 3, that'll be 4, that'll be 5. Okay, so actually if we did 1/4 of a unit, I don't think we'll have enough room. That'll be 6, that'll be 7. Okay, even with the 1/2 unit, I don't know if we'll have enough room, but it's going to be kind of cramped. So anyway, that's that. Remember, in the y direction, each grid box is 1/2 of a unit. So now we'll go in the negative direction. So this is negative 1, negative 2. Let's move that up a bit. Negative 3, negative 4, negative 5, negative 6, and negative 7. Okay. All right, now that's it for our scale. So, and again, if you're like a quiz or a test, or maybe even on a homework assignment, you might already be given the scale, and it really does save you a lot of trouble. That's really nice. But anyway, that's how to get the scale if you're not given one. So now what we do is graph the asymptotes. Pretty straightforward. They're just vertical lines. We already have the equations of them. Graph the asymptotes and plot the 2 points we found in step 4. Plot those 2 points and use them as guides to draw the graph, just like we did with the secant function. Anyway, let's graph those asymptotes. So this one got erased. So let's zoom out a little bit. Okay, this one got erased, but it's x equals negative pi. Okay. When k is negative 1, we had x equals negative pi, and then k equals 0, x equals negative 2 pi over 3. K equals 1, we had x equals negative pi over 3. Okay, so let's graph these 3 asymptotes right here. So x equals negative pi. That's this asymptote right here. So here's negative pi. That's why we went all the way out here, so we can get to that asymptote that we know we have. Okay, so here's our vertical asymptotes. That's going to be x equals negative pi. Okay, and we also had one at x equals negative 2 pi over 3. So if we zoom in a little bit, we see that negative 2 pi over 3 is right here. So that's our vertical asymptote. Okay, so negative 2 pi over 3. Okay, so this is x equals negative 2 pi divided by 3. And then x equals negative 1 pi over 3, so just plain old x equals negative pi over 3, we had one there. Okay, so that's this right here. And come back down also. Okay, so let's zoom out a bit. Okay, so this is x equals negative pi over 3. Okay, so we can always label our vertical asymptotes so that we can be clear and thorough. Now, now we want to plot those points. Okay, so what were the points? They were negative 5 pi over 6, comma negative 3, and negative pi over 2, comma 5. Okay, negative 5 pi over 6, comma negative 3. Okay, negative 5 pi over 6, negative 3, and negative pi over 2, comma 5. So we'll have to zoom out a bit. Negative 5 pi, or sorry, negative pi over 2, comma 5, right about here. So notice these points are pretty far apart, right? They're pretty far apart. That's because of this 4. Okay, this 4 takes the cosecant graph and stretches it out quite a bit, so that those up-down pieces get pretty far apart. Okay, so now the rest of the step says plot the 2 points and use them as guides to draw the graph. What does that mean? What that means is, well, remember, secants and cosecants have that general shape, like, you know, they have the asymptotes, and they open up like that. sort of like a parabola, not exactly a parabola, right? But they just have that similar shape, okay? And they open up like that, so upwards piece, downwards piece, and so on and so forth, like that. So basically we just want to use the points that we just plotted, use those as guides to draw the graph. So this point down here, okay, this one is below this other one. Since this one is down here, this piece is going to be a downward piece, like this piece and this piece, okay? And since this one is further up, this point is going to give us one of the opening up pieces, like this one and like this one here, okay? So, and again, this is why we did t divided by 8, because if we did t divided by 4, we would have asymptote, point, asymptote, point, asymptote, and it would be kind of squished in, okay, which isn't really a bad thing, I guess, but it just wouldn't be a whole lot of room to work with. But so that's if we did t divided by 4, but since we did t divided by 8, we actually have these extra points here, okay, these points here, so it's a little wider because we did t divided by 8, so a little wider, so we have more room to work with. Now, we don't know the exact y-coordinate at this x value or this x value, or this x value or this x value. Okay, and we're not going to do it in the video, but just be careful because if you know, maybe for your quiz or test or for your homework or something, you might have to be more specific, more precise than we're being in the video, which is fine. You can just take these x values and plug them into the function. Okay, so some of these look kind of goofy, negative 11 pi over 12, negative 7 pi over 12, negative 5 pi over 12, but you know, it's a goofy function, right? For cosecant 3x plus 2 pi. So if you put in something over 12 for x, that 3 is going to cancel that with that 12 and give you 4 on the bottom, which is totally fine. Okay, so basically you can evaluate this function at these other points here. You'll get something nice as long as everything works out okay. Well, nice in the sense that it should be on the unit circle, okay? So it might not have a nice value, but it'll be on the unit circle. Anyway, if you have to be more precise, that's what you can do. Just take these x values, plug them into the function, get the corresponding y coordinates. But for this video, we're not going to worry about that. We're just kind of making a rough sketch here. So let's go ahead and do that. So remember, this point is further down, so this gives us a downward piece, like one of these. So open down. Approach the vertical asymptote, never ever ever touch it. Never touch vertical asymptotes no matter what kind of function you are, no matter what else is happening, anywhere at all. Never ever ever touch or cross a vertical asymptote, no exceptions. Okay, so we have that piece there. And then this point up here, all the way up here, so this is going to open upwards, like so. Approach the vertical asymptote, never touch it. And again, these y-coordinates might not be exact the way I drew them, but if you want the exact value, just plug in these x-coordinates. Okay, take negative 5 pi over 12, take negative 7 pi over 12, plug them into the function one at a time. Okay, so this is one complete cycle. Zoom out a bit. This right here is one complete cycle. So let's extend it. Let's extend one more cycle to the right. Okay, so if we extend one more cycle to the right, what's going to happen? So first of all, we know that since the period is 2 pi over 3, that means every 2 pi over 3 units, we have everything starts repeating. Okay, so here's negative pi. So if we go, so let's zoom in again. Here's x equals negative pi. So we have a vertical asymptote there. If we go 2 pi over 3 units to the right, we'll be at x equals negative pi over 3. Where hey, guess what? There's another vertical asymptote. Okay. Here's x equals negative 2 pi over 3. Okay, if we go 2 pi over 3 units to the right, we're going to be at x equals 0, right? Negative 2 pi over 3 plus 2 pi over 3. Okay, negative 2 pi over 3 plus 2 pi over 3 is just 0. Okay, so at x equals 0, we're going to have another vertical asymptote because the period is 2 pi over 3. Okay, and every 2 pi over 3 units, the graph starts repeating. Okay, so since we have a vertical asymptote here, we'll have another one 2 pi over 3 units to the right, which is right here at x equals 0. Okay, and actually, let's go back to our steps. So what we're doing now is step 6. Okay, we finished step 5. Plot the points and smoothly plot the 2 points and smoothly, or just rather use them as guides to draw the graph. And then step 6, use the period and general equation of the asymptotes to graph more cycles if necessary. Okay, so what we're doing here is using the period, but we could use the general equation of the asymptotes. Remember, k equals negative 1 gave us this, k equals 0 gave us that, k equals 1 gave us that, k equals 2 will give us this one, k equals 3 will give us the next one, k equals 4 the next one after that, and so on and so forth. K equals negative 1 gave us this, so k equals negative 2 will give us the next one to the left, and so on. Okay, or we could just use the period, which is what we're doing. Okay, so anyway, this is x equals 0. And then if we go, oh sorry, let's start it here, negative pi over 3. So if we go at negative pi over 3 and go 2 pi over 3 units to the right, that's negative pi over 3 plus 2 pi over 3 Well, let's zoom in a little bit. So negative pi over 3 plus 2 pi over 3, that's negative pi plus 2 pi is 1 pi, so this is just pi over 3. Okay, so if you're at negative pi over 3, you go 2 pi over 3 units to the right, you're going to be at positive pi over 3. Zoom out a bit. And then we'll have another vertical asymptote right here. Because every 2 pi over 3 units, the graph is repeating. Okay? So if we have a vertical asymptote here, we're going to have another one, 2 pi over 3 units to the right, which is right here at x equals pi over 3. Okay? All right, and now, again, so here's negative, so we can take negative 5 pi over 6. Negative 5 pi over 6 is the x-coordinate at this point here. We can add 2 pi over 3. Okay, if we have to show work, we can do it like that, negative 5 pi over 6 plus 2 pi over 3, and we'll get negative pi over 6. Or we can just kind of look at the graph here and say, okay, zoom out even more. So this right here, okay, this right here is one complete cycle. Okay, so if I want to duplicate that, so I have the bottom piece and then the top piece. Okay, so open, down, open, up. So here, if I want to duplicate that, open, down, open, up. So if I duplicate that, then negative 5 pi over 6 is exactly halfway between these asymptotes here. Okay, negative 5 pi over 6 is exactly halfway in between. Here, negative pi over 6 is exactly halfway in between these asymptotes. So it's going to have the same y-coordinate. But again, if you're not comfortable with that, you could just do negative 5 pi over 6 plus 2 pi over 3. Why 2 pi over 3? Because the period is 2 pi over 3, so every 2 pi over 3 units, everything is repeating. So multiply by 2 over 2 to get a common denominator. So negative 5 pi over 6 plus 4 pi over 6 is negative pi over 6, okay? Which is what we have right here, negative pi over 6. And then same y-coordinates. And then this opens up the exact same way that this one does because it's periodic with period 2 pi over 3. And again, approach the vertical asymptote, never ever ever touch it, never cross it. No exceptions for vertical asymptotes, no exceptions. Okay, so that's this piece. Now this piece up here translates over to this piece. So negative pi over 2 is exactly halfway between these asymptotes. So positive pi over 6 exactly halfway between these asymptotes. So that's where this point's going to be. Or again, if you don't like that, if you don't like thinking about it like that, just take negative pi over 2 and add 2 pi over 3. Okay, so denominator 2, denominator 3, the least common denominator is 6. So multiply this by 2 over 2, multiply this by 3 over 3. So this is negative 3 pi over 6 plus 4 pi over 6, which is plain old positive pi over 6, which is exactly what we have right here. Okay. Okay, then open this up the same way. But again, if you have to be more precise than we're being in the video, if you have to be more precise, more specific, more accurate, if you just can't make a rough sketch like this, take these x-coordinates, plug them into the function, okay? Pi over 12, pi over 4, even though pi over 12 is goofy, this 3 is going to, take care of that for you, okay? It's going to make 3 times pi over 12 is pi over 4, so that's going to be okay, okay? But again, we don't want to worry about that too much in this video. We just want to focus on getting the general shape here. Okay, so that's 2 complete cycles for the graph. So we could extend one more and go 3 cycles, but this stuff is in the way now and it's all the same stuff. Again, so, and also these are kind of messy numbers, so let's not worry about that. So anyway, this is y equals 4 times the cosecant of 3x plus 2 pi, and then plus 1. So that's how we graph a cosecant function, and we see it's really pretty much identical to graphing a secant function. The only difference is we use k pi for the general equation of the vertical asymptotes instead of k pi plus pi over 2. Anyway, that's graphing a cosecant function.